Welcome to Spring LIB.
This is the answer to Chapter 31, problem number 62 from the Smith Organic Chemistry textbook. And this problem is asking us to think about the reaction of urea and formaldehyde. And we're told that this reaction forms a highly cross-linked polymer that's used in foams. And we're asked to suggest a structure for this polymer. This problem isn't asking us to draw a stepwise mechanism, but it is probably best to think about this, step by step, in order to sort of see how we might form the pieces of this polymer and then how they might cross-link. So we're starting with urea and formaldehyde. And so they're going to react with one another initially to give us something like this. And then we can imagine if we were to protonate that alcohol, the alcohol would willingly leave. And just like we saw in the previous problem, problem number 60, we would end up with an intermediate that looks like this. So with a nitrogen with a positive charge on it, double bonded to a CH2. So again, the nitrogen is going to have a positive charge there. And so that's going to allow another nitrogen to come and attack that carbon in the CH2. So here we can actually do this. So another molecule of urea is going to come here. So another urea. And we'll get to here. So now we can repeat this. We can add a formaldehyde again now to either end here, really. So what it ends up being is we'd actually add a formaldehyde to both ends. So actually, rather than look at it that way, what we could do is add another. Oh yeah, okay. So what we could do is add a formaldehyde here, for example, to that nitrogen. And so if we were to do that, the product that we get from that would look like this. And then we could use a formaldehyde to sort of bridge this gap here between these two nitrogens. And so if another formaldehyde comes in there and bridges that gap, we end up forming a six-membered ring. So we have this six-membered ring with three nitrogens in it. And then from here, formaldehydes can link any two nitrogens, so we can rapidly create a pretty sophisticated molecule. So we can rapidly get like interlinking and complexity of all kinds going on here. So right. So as you can see, we've pretty rapidly established a pretty heavily cross-linked, interlinked polymer, um, and so okay, yeah. So the problem was just asking for a structure for this polymer, and they told us it was highly cross-linked, and so that's what we've created here. So this is the structure of the highly cross-linked polymer that the problem was looking for. So that's the answer, and again, that's the answer to chapter 31, problem number 62.